You are accused by your employer of being a drug user. Today, we are going to be using what we just learned, the definition of conditional probability, to investigate a problem that I find very interesting because it's a little bit unintuitive. And by the end of this video, you should be able to apply mathematical findings to build arguments and justify positions, and you should be able to apply the definition of conditional probability to solve multi-step problems. A drug test is 90% accurate. 1% of the population are drug users. What is the probability that you are a drug user given that you test positive? The first and hardest step will be to decode this problem using probability notation. So first, let's label some events. Let D be the event that someone is a drug user. And let this little plus sign represent the event that somebody tests positive. So the first thing I'm going to investigate is the probability of D. Probability of event D. What is the probability of event D from our given information? The probability of this event is 1%, or 0.01. Now, let's investigate. What is the probability from our given information of somebody testing positive? Well, that information isn't directly given in our question, in the information we're given. What this first line tells us, a drug test is 90% accurate, it tells us that the probability that somebody tests positive is 90% if they are a drug user. So the probability that someone tests positive, given that they're a drug user, is 90%. And then what is the question asking us to look for? What's it asking us to investigate? That's that third line here. What is the probability that you are a drug user, given that you test positive? That's going to be the probability of D given our little plus sign. Okay, I wrote our key information up at the top here. So how can we investigate the probability of D given plus sign? Well, we can use our definition of conditional probability. So using our definition of conditional probability, how can we rewrite the probability of D given plus sign? We get that the probability of D given plus sign is the probability of D intersect plus sign over the probability of plus sign. So we don't know either of these, but we do have enough information to find these. So first, let's just look at the probability of D intersect plus sign. I'll put a star next to it. This is the one that we are looking for. Okay, so also from our, oh, here we go. Let's find the probability of D intersect plus sign. So also from our definition of conditional probability, we can write that the probability of plus sign given D, which is something we do know, is equal to the probability of D intersect plus sign, which is what we're looking for, over the probability of D, which we also do know. So we can rewrite this to isolate the probability of D intersect plus sign as such. The probability of D, we multiply both sides by the probability of D. I can write that in, times the probability of D, times probability of D. And we know what both of these are, so we can substitute in our values from our givens up top, and we get that the probability of D intersect plus sign is 0.009. So we can write that up here with the rest of our given information, because we know that now. Okay, so now let's investigate the probability that somebody tests positive. So two groups of people may test positive. We have our true positives, which is the drug users that test positive, and we have our false positive, the non-drug users that test positive, because we don't have a 100% accurate test. So looking at the true positives, we are looking at the probability of D, drug user, intersect test positive, which we already found. We know that. We know that that is 0.009. Now let's look at what is probably the harder case, which is false positives. So what we're investigating here is going to be the probability of not drug user intersect getting a positive test. So using our definition of conditional probability once more, we're going to rewrite this as the probability of positive test given not drug user times the probability of not being a drug user. And using this, these are just the complements of some of the information we have up here. The probability of not being a drug user, well, we know the probability of being a drug user is 1%. So that's going to give us that the probability of not being a drug user is 99%. And we know that the probability of getting a positive test score, given that you're a drug user, is 0.9. So that's going to give us that the probability of getting a positive test score, given that you're not a drug user, is 0.1. And that's going to give us 0.099 for the probability of getting a false positive. So you either get a true positive or a false positive. That means that the probability of getting a positive is going to be their sum, which is going to give us that the probability of getting a positive test score is 0.009 plus 0.099, giving us 0.108. So I've added the probability of getting a positive test score to our given information at the top, and now we have enough information to substitute everything in and get our answer. So just substituting in this and this, we're going to get 0.009 over 0.108, which is going to give us 0.083 or 8.3%. So in this specific problem, the probability that you are a drug user, given that you test positive for drugs, is 8.3%.